Okay, go to page 81. Let's start page 81. All right, screen echo, let me explain what this next part of the topic is. So we did this last class, and I hope you're clear about it. So current is the rate of flow of charged particles, number one. Number two is that charges are quantized. Quantized means they're whole numbers. So the number of charges that you can have is like 1, 2, 3. There's no fraction possible, okay? Our Q equals to IT. A quantized hour, well, this is more for A2. There's nothing really about it in AS. But the last one, for current carrying conductor, the expression, a expression the way and this expression will now become your tool to answer anything and everything in terms of a circuit. So whenever you want to explain circuit behavior, we used to stick to V equals to IR. You know, voltage bar to say current bar way or something like that, right? But A level station, this is the one. And this is much better than V equals to IR. Okay, it explains far more things than what we can achieve with V equals to IR. So for example, like a thermistor, you have heard of the thermistor, right? What does the thermistor do? As temperature increases, the thermistor's what decreases? Resistance, right? Now, V equals to IR can't explain that, right? V equals to IR doesn't explain properties. This one will explain that. This will explain why LDR works. This will explain why thermistor works. It'll explain why resistors increase their resistance when temperature increases, right? All of these are based on this last equation out there. So there's a question, when should we use the Q equals to IT graph? Actually, last class we used this, but clarify Q equals to IT data, this formula, right? You can use it anywhere. Okay. However, when I give you a question, I ask you to use a graph here, right? When I'm also graph possible. And the question is, when should we use a graph for Q equals to IT? No idea. Well, what do you guys feel? When should we use the graph? Q equals to IT formula, and I use graph use personally, right? When is it needed to use the graph rather than using the formula? Right. I'm only physics are fundamental rule, not with electricity. Remember, there was a formula speed equals to distance by time. And when speed equals to distance by time was only applicable if your car was going at what speed? Right. Q equals to IT is only applicable if your current is what? Constant, right? So Jockney change even in your motion equations, right? What did you resort to? Graphs. But of course, motion atobar change that they eventually came up with Suvat equations for them, right? Current or Suvat equations, no one would want for it. But current if they change, what do you tend to draw? A graph. Okay. It's not a sheer shot solution though. যদি তোমার current randomly change, the graph doesn't help either. Okay. But if your current is changing constantly, like it's here, you should look for the graph. So whenever you have a constant current or constant anything for that matter, equations are like fine. But whenever you have change, we have to go for graphs. So আমি একটা জিনিস অ্যাড করে রাখি এখানে। It's unfortunate যে তোমাদের সিলেবাসের লিমিটেশনের জন্য তোমরা শিখতে পারো না, but you learn in math. Change আসলে কিন্তু equation পাওয়া যায়, and that's known as what? Differentiation. So differentiation যখন করা হয়, you do like a rate of change of something, right? So yeah, equations seem to exist for even for graphs that are changing. It's just for our syllabus, we don't have calculus, we don't have differentiation and integration, right? So we have to stick to very nominal tools out there, like area graph. Okay. Right. So anyway, actually, it's a very interesting topic, a topic that we have skipped in all of those actually. Kind of acknowledge for a while, so the question is, how fast is it? That's what I'm going to answer. Okay, what is the speed of the current? So if I show you here, right away, and let me they turn on right? So what do you think might be the speed of our current? Current fast for it. Like fast, so radius, right? So how fast is it? What's your guess? Do you think it's speed of light? Actually, speed of light, can you see a delay? I don't know if you can read it or not. isn't it, right? So you're saying that you can see the slowness of light. It just so what do you think? My question back again, do you think electricity is as fast as light or slower? It's extremely slow compared to light. Okay, light is speed of just something like 3 into 10 to the power 8, right? Electricity, like current passes through the wire, right? It is speed of 10 to the power 4, 10 to the power 5. It is fast. Okay, don't get me wrong, but what isn't it as fast as light? Okay, it's faster than sound, it's faster than many transmission processes out there, but it is not as fast as light. Okay, so my question is, how fast is it? So somebody designed an experiment to see how fast current and electricity flows, right? And the experiment went something like this. Experiment tomader syllabus and night, but you don't have to do the experiment, but it's a very simple demonstration actually. So demonstration day, it's a tray here. So you take a tray like that, okay? And what you do is, in the tray, you place an electrolyte. Do you know what an electrolyte is? What is it? Yeah, electrolyte is basically a solution that contains free-flowing ions, which can allow what to pass through your solution? Current, right? Can I use distilled water as my electrolyte? No, it's a very poor electrolyte. Cannot distilled water contains no what? Ions, right? So I need to have some kind of a solution. So distilled water ke ami electrolyte banai felte pari very easily. By doing what? Yeah, add salt, like NaCl. Literally just put some salt into it, it becomes a very good conductor. You can actually see this experiment. Chemistry like you take distilled water, place a circuit through it with a lamp, right? Lamp কাজ করবে না. Start water into the water, pour in salt, suddenly lamp কি করা start করবে? Glow করা start করবে. The moment the salt falls into the water and dissolves, right? What's released in the water? Ions. And for current, do I need like something that flows, or do I need charges that flow? Charges, right? And once you put your NaCl into the water, you have Na plus and Cl minus. Those can help your current flow around, right? So anyways, that's very elementary idea. So what we do is we take our tray here and we place a electrolyte here that can conduct just water, a bottled water, mineral water, use, okay? Now the idea was to see electricity, right? Electricity কত তাড়াতাড়ি যাচ্ছে যদি দেখতে চাই, the person came up with this ingenious plan. সে কি করছে? To place like a plate here, metal plate, okay? We have names for it in chemistry. They're called electrodes. So this is a metal plate placed here, and what he did was he placed another metal plate here, and these metal plates were connected to a power supply. Okay, so there are two metal plates here connected to a power supply, and it goes to positive, and from there it goes to negative. Okay, so when electricity tries to flow, you'll see what passes through this current, right? But the problem is, can you see electricity like actually flow? No, you could if you could see what electrons flow. So when electrons ke dekhte parta, tale tumi ki dekhte parta? Electricity flow, right? So is there a way I can visibly make the charges show up that I can see them flow? But our point is, on current pass, right? I want to see the current pass. Like, I want to literally see current. So what can I do there? Because this is a transparent liquid, current to colorful kichu na, right? So how do I, color current, if you could say? So that's the solution that they came up with. The person is actually pretty straightforward. So the person used salt here, a very famous salt for its color property. It's a purple color salt that has a poor solubility, but once you provide it some kind of energy, it becomes very soluble. Do you know what this is? A purple color salt could be popular in chemistry. Yeah, have you heard of it? Potassium permanganate? No, acha ব্যাপার না, chemistry ওরকম knowledge লাগবে না এখানে, আমি বলে নেই তোমরা যদি না জেনে থাকো। This is called potassium permanganate. It is KMnO4, right? And it has two ions in it, key ions, K plus and MnO4 minus. Do you know what provides the purple color? Yeah, it's not the potassium. Potassium or flame test purple shall be purple. No, potassium is actually colorless. Okay, so what you do is the manganate ion, the minus ion here, has what color? Purple. So if you can make current pass through this, solution, and if potassium permanganate and manganate ions are carrying my current, right? What would I see flow? Purple color. When I'm talking about purple color just through my solution. Do you agree with what we're trying to do right now? So if I could show current flow, I would see what flow through my container. Purple vapor, purple, manganate ion. So the person turns on the circuit, okay? And that's when something very strange happens. Key strange hoy. The person places a lamp here to see if the circuit is working or not, okay? And the moment the person turns on the circuit, right? The instant the person turns on the circuit, what does the lamp do? Glow. There's no, delay whatsoever. Instant glow hoche. But purple kichu nai. There's no purple vapor, purple nothing showing up, right? So that's a bit of concern because we thought who was supposed to carry the electricity through the fluid? Manganate ions. The manganate ions to kono kichhui dekha jacche na. The purple color, nothing is showing up. But what's the lamp doing though? Glowing. So what's happening here? So what happened was, as the person waited for a while, he started to notice something. He started to notice from this potassium permanganate aste aste ki ber hocche? Purple vapor. And the purple vapor is flowing through the container towards the positive terminal there. And that confirms that what is actually flowing through your solution? Manganate ions. But are they flowing at the speed of light? No, this is really slow. Its speed tomode jante hobe for estimation purposes, 1 millimeter per second. But 1 millimeter every second. তার মানে হচ্ছে তোমার 1 meter cover করতে 1000 seconds লাগবে. 1000 seconds is a lot of time. Okay, so it's really slow. So here comes the biggest problem. Current, right, is really slow, but lamp glows instantly. How is this happening? So আমার যেটা এখন বের হলো from what we just did here is that when I turn on and off the lights turn on and on instantly. But the electrons that is carrying, or these electrons that are going through the wire, are moving at what speed? Extremely slow speed. Okay, like 1 millimeter, 2 millimeter per second. So the question is, didn't we learn electrons are the ones that carry the energy? So ora jodi eto slow hoy, why does the lamp glow instantly? And that's where we come across one of the biggest misconceptions in a circuit. Charges, right, don't need to flow to the component to transfer energy. How do they transfer energy? Through contact. So it's called a domino effect. So data hoy is that you have one charge here, you have another charge here, you have another charge here, right? They're all in series, like, at the line A. Once you push one of the charge from this side, right? That push, the effect of the push travels through all the electrons at what speed? Same speed, obviously, but like very low speed or very high speed? Very high speed. And that push is what causes the lamp to glow. But তুমি push করে যখন নিয়ে যাচ্ছ, each of these electrons are moving at what speed? Really, really slowly. If you could see an electron through the wire here, right? On the class duration, we did this math with the other previous years. A socket থেকে ওই ল্যাম্পে electrons flow করে না, because our class is not that long. Because the electrons are so slow, এই পুরা তার দিয়ে travel করে 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 ওইখান থেকে গিয়ে ল্যাম্পে যেতে takes about 2.5 hours. Whereas, we will be done before that. So do you understand how slow electrons are? But the effect of electricity is what though? Instant. Okay, instant one is really fast, not speed of light fast, but it's instant. Okay, so that's when we came across this thing that the effect of electricity is very fast, but the current itself, the charges that are actually flowing, is what? Really slow. Okay, their speed is very slow. আর আজকে আমাদের হচ্ছে main task হচ্ছে to understand why is it slow and find an equation for that. There's a name for that speed at which the electrons flow. It's not called current, it's called drift velocity. So let me explain what's the difference between speed of charge versus current. Current definition key, rate of flow of charge, right? Our drift velocity হচ্ছে how fast what is moving? The electrons. Electron into physical objects like numbers, 1 electron, 2 electron, 3 electron. Think of an electron flowing like that, right? So to give you a better context, think of a car as an electron and think of the passengers as the charge. Okay, the speed at which a car is moving, is it the same at the rate at which passengers are transferred? Think about it. Okay, the speed at which the car is moving, is it the same as the rate at which passengers are transferred? No, if your bus is traveling 100 meter per second, right? It's carrying 50 passengers, right? How many passengers is it transferring per second? 50. 50 into is like, number of passengers, but car travel করতেছে কত? 20 meter per second. Are these two numbers same? No. So the vehicle that carries the charge is your electron, which is very slow. And the charge is what the property is, and that is what current is dependent on. Okay. So don't worry, I'll give a derivation to them better. Okay. So yeah, this is the premise of what I'm going to derive right now. It is one derivation that I can confirm exam ashe, okay, because it has come before. There are a lot of derivations I make you do. I haven't seen them yet, but this does appear, okay? So এটা পাশে কোনো blank page করলে best হবে, উপরে heading দাও, drift velocity equation. Oh, so if you just buy normal water, it's just pure water with maybe some salts in it. Electrolyte is a water with dissolved what? Extra salt. So that's why you'll find it sweet or salty. And then the name electrolyte comes from your body. So our body has water in it, and if the water is pure water, you'll die because of osmosis. So the water in your body needs to have water in it, salts, right? That's why when you sweat a lot, they'll ask you to drink an electrolyte drink because you want to refill the salt back again. So that's why it's called an electrolyte drink. It's basically saline water. Yeah. Yeah.
So why doesn't the water molecules transfer charges like that?
They did, right? Because otherwise, without the flow of my electrons or my purple manganate ions, current shouldn't have flowed. So basically what happened was the manganate ions pushed the ions in the water. By the way, the water I used was the electrolyte, right? So it already had ions in it. Those weren't colored though. So the colored ions belong to whom? Manganate. So you have your manganate ion here, you have the water ion here, like, let's say sodium chloride Cl minus, right? So this manganate pushed the Cl minus, the Cl minus pushed the other one, and that's how the effect of electricity got transferred. But that manganate ion took very long time to move along the liquid. That's what we eventually saw. So the effect is instant. There's nothing to see, but the speed at which the ion moves is really slow, and that's why it took a lot of time for the purple vapor to show up. It wouldn't happen. The electricity wouldn't flow to begin with because potassium permanganate didn't dissolve yet. So the pure water is still what? Without ions, right? Current wouldn't flow. Right, so we have this wire here. এটা হচ্ছে এটাকে আমরা বলি হচ্ছে cross sectional area. Cross sectional area A. This is the length of the wire. L. And this wire contains charges. And these charges are your electrons for a metal wire. So I'll just call them Q, charge. And this wire has a property called N, which is a new term for you guys. So it's very important you understand. Charge, carrier, density. It's represented by N. Okay, so shall I just screen it echo? I think most of these are very straightforward, self-explained. Cross-sectional area key. This is the frontal area, right? So in the exam, if you call this area, this would be incorrect. Okay, because area could also imply what area? Surface area. There are a lot of other areas out there, right? So be very careful to acknowledge the fact that this is your cross-sectional area, the front area. Okay. Acha, next হচ্ছে length of the wire. That's pretty straightforward, right? Q টা কি এখানে? Q is the charge of every charged particles here. So every dot that you see here, these are charged particles out there. Or their charge হচ্ছে Q. All right. Now, এটা একটু carefully শুনো, and this is important. Charge carrier density. What does charge carrier density mean? So charge carrier density refers to the number of free flowing charges per unit volume of a material. Our but শুনো carefully. Number of free flowing charges per unit volume of a material. Okay. Charge carrier density is not the same as the number of electrons you have in a material. Do you understand what I'm trying to say? So আমার এই যদি পেনটার number of electrons থাকে 1 billion, charge carrier density for this pen, right? It's 0, because this is an insulator and the charge carriers that I'm talking about are not freely flowing. So what's the charge carrier here? 0. So for your material to be a conductor, right? What should the charge carrier density number be? Greater than 0. Okay. So there are some materials that have 1 to very low number of charge carriers. They're not conductors, like good conductors, but they're still conductors. For insulators like the wood or plastic, charge carrier value ki hoy? 0, right? Do they have electrons though? Plenty. Wood has more electrons than copper, but is it a conductor? No, because the electrons are what? Bound in the giant covalent structures and whatnot, right? Are metals some of the what are the electrons? Free, delocalized. So charge carrier density is like delocalized electrons, but I wouldn't call it delocalized because our electrolyte model to electrons charges and you can't call them delocalized, right? So the idea is that these are what charges we are referring to? Free flowing charges. Okay. And charge carrier density key, the number of free flowing charges per unit volume. I mean 1 meter cube er moddhe koyta paba tumi? Okay, it's a very important number. So yeah, that's M there. So let's start the derivation. Shobai screen e dekho, it's a very easy derivation, but ekbar bujhe felle you not forget this, I feel. So can you tell me the total number of charge carriers in this wire that I have provided? Okay, total number of charge carriers in the wire. Can you come up with a formula for this? What's the total number of charge carriers in this wire? Charge carrier density, by the way, definition of ki N is equal to number of charge carriers. Number of charge carriers divided by what? Volume. Okay, volume of conductor material. So yeah, can you tell me what is the total number of charge carriers in this wire that we have? Online on a so yes, yes, exactly. N into V, right? N is the density and V is the volume. So I'll get the total number of charge carriers in the wire. Now, দেখে নাও পরে লেখো, আমি আর গুছে আর একটা ডেরিভেশন দিব, ওটা কপি করো। So next হচ্ছে total charge in the wire. This is the difference I wanted to explain to you. The difference between number of cars and number of passengers. Number of cars the charge carriers. Our passengers the charge itself. Okay. Can you tell me how can I find the total charge in this wire? By the way, what is this Q? Charge of one single charge. One single charge Q. My question, total charge is entire wire. Q into Q into N is the total number of particles, and then you multiply that with Q, you get the total number of charge. That one charge is total charge into the total number of particles. What is the total number of particles? NV, right? So therefore this is Q and NV. Okay. Are you with me so far? Now this is Q total. That is Q and NV. Q total the total charge out there. You agree with me so far? এখন আমরা যেটা করব, we will find the rate at which the charge is moving. Rate বের করতে হলে there's only one thing you can do. What do you do? Divide by time, right? So I'll divide this side by time. I'll divide this side by time as well. What is the total charge transfer per unit time known as? The total charge transfer per unit time. Current, right? Current. So left side is total charge by time, current, right? Our right side you get Q and V divided by T. So I'm going to break down. Can you look at the material I've provided you at the top and tell me what is the volume of this material? A into L, right? So you get Q N A L divided by T, right? So next আমরা যেটা করব, we'll do Q N A L তার সাথে T টাকে নিয়ে আসবো. I can do that, nothing illegal, okay? So what is length per unit time? The speed, right? So wouldn't that literally tell me how much time the charges took to travel the distance L? And wouldn't that tell me how fast they're moving, right? And that is your drift velocity, okay? So eventually we get the equation I equals to NA Q is a small v, okay? And that v is what we refer as the drift velocity of the electrons. A drift velocity কেন নামটা? Why not just velocity? There's a big reason behind it, ওটা একটু পরে বুঝতেছি, okay? Drift velocity of the charges. Yeah, that's the derivation. দেখি আরেকটা version ছিল, ওটা তোমাকে দিচ্ছি. Question এখানে, can charge carrier be positive? Absolutely. Okay, কোনো problem নেই charge carrier positive নিয়ে.
So in a conductor, all the charge carriers, all the electrons are charge carriers.
Yes. So their Q value would be the charge of an electron.
So why are we multiplying NA?
NA.
So can you go?
Yeah, I just take now. Go there. Yeah, বলো.
Total number of charge carriers in the wire. This is the same as the two charge in the wire.
No. Total number of charge carriers হচ্ছে the number of electrons you have. Let's forget electrons, the number of charges you have, charge carrier. So let's say the charge carrier for us is copper sulfate Cu plus 2. So each of them are Cu plus 2, right? But their charges are not charge of an electron. Their charges are double the charges of an electron, right? So if I have 10 copper sulfate ions and each of them have 2 charges, right? What's the total charge? Right. And if I have 10 electrons and each of their charges is 1, what's the total charge? 10. So do you see the charge number is like what carries them, but how much charge they carry can vary, right? So ekhane hocche the number that I found first, right? NV tells me how many carriers of the buckets are out there. And the next one is how much charge those buckets carry, which can vary.
It can be positive or
Negative, positive, more or less, everything is possible. Okay. Right, so this is the derivation. Left, right, do same finish. Okay, just write it down. I've provided like more breakdown of what each quantity represents. Okay, so yeah, this is the derivation. Mainly, the thing that you need to know is this: যে কেমনে হচ্ছে values গুলোকে derive করতে হয়. So, anyways, copy করে now, and then I will explain to you further why is this called drift velocity. How much is the charge of a charge carrier? The charge of a charge carrier is the charge of the electron, for example. So charge carrier in a wire are the electrons. So charge got away. 1.6 into 10 to the power minus 19. Do you remember? Right. So away. Can you explain the NQ, Q, and V? Sure. So this value that you see here, right? This one, it's total. Actually, like the total number of charge carriers in the wire. This one that you see here, it's the total charge in the wire. So charge versus charge carrier is the different units, charge in the wire. So what's the difference between a charge and a charge carrier? So a charge carrier is basically like a particle. Okay, so this is a charge carrier.
Can we say electron for the wire?
Yeah, for a wire, it's electron, right? So charge carrier is basically the particle, and the charge that's inside is what we normally refer as the value of the charge. So you can quite a charge carrier that it's older. Okay, two. How many charge carrier have I drawn? One. Yes. How much charge have I drawn? Yeah, very good. It varies. It depends on what this is. This could be Cl minus the charge koto -1. It could be Cu plus 2 was the charge. Yeah, it could be Al plus 3 was the charge. 3, right? So it's basically what that particle carries, right? So আমাদের obviously relative charge নিয়ে কাজ করতে হয় না. So if it's an electron, the charge of an electron is something you need to know. 1.6 into 10 to the power minus 19 coulomb. It'll be given in the booklet behind, but you have to know that you have to use the absolute value, not the relative value. So yeah, that's what a charge carrier versus charge is. No, not for math. For our math, you ignore the sign. Q and V is electrons, right? No, Q and V electrons. Can anyone tell me NV versus Q and V which is the number of electrons? NV and Q and V which one is number of electrons? NV, right? And the total charge would be which one? Q and V, right? Which is number of electrons into the charge of each electron.
What is Q?
Charge of single electron or single charge.
Battery know which charges to use.
So this is interesting. You normally when you have an electrolyte and there are ions out there, right? They do have the same value. So Cu plus 2, SO4 minus 2, K plus MnO4 minus 1. So they're both one value charges, plus and minus, right? So what happens is they just keep flowing both direction. For a battery, it doesn't really matter if electrons are coming in or if positive charges are going out. As long as there's a flow, somehow it's fine for it. So if you have a battery where there are electrons coming in and positive charges going out, right? It would be a better battery. Why? Because you have double the impact. So therefore, having more ions, you see here, gives you more current. That's why if you have a solution that's KMnO4 minus or KMnO4, right? Versus copper sulfate, you find there's more current when you have what? Copper sulfate. Why copper sulfate will have more charge carrying, right? Do you guys have the mole number, charge, energy calculation in chemistry anymore? The 96500 number. 1 mole, how much energy is transferred during electrolysis? No. A2H. Or A2H. Okay, yeah, some of you wanted the Wazer entire notes, right? But according to because you're done with waste, so upload for you. Q is the charge of a single charge carrier. Exactly right. Charge carrier 1, charge such a very good number, that's Q. Okay, so wait to দেখো, are you guys done? Copy করা? আচ্ছা, I want to show you something important. দেখে নাও এদিকে. So why do we call it drift velocity? What's the reason for the word drift in it, right? So খুবই important একটা জিনিস দেখো তোমাদেরকে. সবাই স্ক্রিনে দেখো. The origin of charge flow. I'll give you time to copy it down again, but আগে এটা একটু বুঝে নাও. Right, where does the term drift velocity come from? So we need to go down to the level of the electron to understand what's actually happening. So একটু এদিকে দেখো. Do you guys remember all levels that we studied how charge flow করলে a material heats up and as like a resistor heats up filament lamp, right? And what was the reason behind it? As charges flow through the wire, the charges collided with the positive lattice ions and they transferred their energy to the ions, right? And what did the ions start to do? Vibrate more vigorously and they created more obstruction and whatnot. So see what's happening here. If I look at a typical metal, you have these positive ions here, right? And they form a particular bond and structure. Do you know what the bond name is? Metallic bond. Have you studied metallic bonds? Acha, what I want you to understand is that the positive ions are very rigid and very closely packed and very well bound. Lattice arrangement bola hoy, right? Now look at this very carefully. You have an electron here that's trying to pass through the wire, right? So the first question is, what makes the electron move through the wire? खूब fundamental question. What makes the electron move through the wire? Electrical energy provided is true, but any other reason? Yes, very good. So what happens is it's electrostatic forces. So force over distance results in what? Energy, right? So jeta kora hoy, on one side, you have the what terminal of the battery, the negative terminal of the battery. And on the other side, you have the what terminal of the battery, the positive terminal of the battery. So I'm ekdom simplified version. So you have a positive terminal of the battery on this side, and you have a negative terminal of the battery on that side. What would the negative terminal do to this electron? Repel. And what would the positive terminal do to the electron? Attract. And because of these forces, what would the electron do? Move, right? How fast does this electron move? Extremely fast. We have calculations of this in A2 now. Like typical speed would be 1 into 10 to the power 6, 7. That's the speed at which an electron would typically move. Very easy to make an electron move. It's one of the lightest particles out there, right? But this electron's journey is not that straightforward. So as this electron is made to move, right, through this, right away, now what I have drawn is not the true picture. The true picture is way worse than this for the electron. How are the gaps here? Barely any, okay? Gap of it's like barely any kind of gap you have available. So when your electron is trying to move through this maze, right, of positive ions out here, what does the electron's journey look like? Let's try to picture that. So what so it'll go there and it'll hit this thing. The moment it hits this thing, what does it do? Sudden stop. It'll try to make its way out. And again, it finds a gap. Again, what does it do? Accelerate. Again, what does it do? Stop. And then it makes its way out somewhere here. And then goes and then stops. Makes its way out here. Goes and then stops. And then stop and go. So every time it has a free path to move. But time like, that free path that's available, is it very fast or is it very large or very small? Very small, right? So just think of, driving through Dhaka traffic. It's exactly the same thing, right? You get that 1 inch and everyone just goes for that 1 inch full speed at the right? No one gives their chance. Right? So yes, of course, for how many seconds? So, barely 3 seconds, at max 4 seconds, right? You get my point. So the issue is, it's a what kind of a motion? A start-stop motion. Jai thame, right? And if somebody is looking at this from far, right, it'll look as if the object is not moving fast and forward. What is it doing? Slowly, just, drifting forwards. Do you see how boats that are being, tied in the waves, they're just like slowly drifting back and forth, ওরকম একটা motion হয়। So the velocity of an electron is very fast, but the what velocity of the electron is very slow, which is what velocity? Average. So if you look at the average, yes, to me 100 km/h Dhaka to Uthao. What's the average speed of Dhaka? 4 km/h. It is 4 km/h. It's been proven. The average speed in whole Dhaka is 4 km/h. But তোমার গাড়ি তো 100 উঠে 80 উঠে for how long, right? It's mostly কিসে যাচ্ছে? 4. Okay, that's the average speed. So same goes with the electron. So if you look at an electron here and you look at its journey, and this graph is something you need to know, you'll find that the electron does go very fast at moments, but most of the time it is just slowing down. So this zigzag pattern is the life of an electron. So when you're an electron, your motion to the positive ions would look something like this very abrupt start stop motion. And once you take the average of this start stop motion, you'll find that it's a very what velocity? Low velocity. So when we write v, can I say that's the speed of an electron? No. So what speed of an electron? Average speed of the electron. তার জন্য অনেক জায়গায় লেখা থাকবে কি average velocity. So average word important here. Are you with me so far? So yeah, this is the graph. A graphটার হচ্ছে axis টা হচ্ছে can you tell me y axis কি হবে for the black line? Yeah, the velocity of the electron, the actual velocity of the electron. Okay, so this is velocity of electron meter per second day, and the x-axis is what? Time. But the blue line represents what? The average velocity, right? Average velocity, and this average velocity is what we refer as the drift velocity. Do you understand now the difference? So when you saw the purple vapor move slowly like that, the purple vapor was having a difficult time moving through. That's why it was slow. Okay. তোমাদের টেস্ট পেপার গুলো রেডি হয়ে গেছে। I'll upload the marks and I'll keep it up front. তোমরা next class নিয়ে নিও।
Join lab, but seat 99
তুমি লাস্ট কবে কন্ট্যাক্ট করছো? লাস্ট ক্লাসে। আচ্ছা, আমার জানার মতো একটা সিট ছিল, আমি আবার কথা বলে দেখি। হ্যাঁ আমি তাহলে আজকেই কথা বলে দেখি। 7 to 8 তো মনে হয় নাই for sure, 8 to 9 থাকতে পারে। I know that the ভালো but 8 to 9 ছাড়া নাই, উইকে একদিন তো ম্যানেজ করতে হবে, স্যাটারডে। তারপর ক্যাব 4টা থেকে 5টা। আমি এমনি দেখি আগে অ্যাভেলেবল নাই, তারপর আর আমার পরীক্ষার আগে সব ভালো হচ্ছে 20টা ক্লাস হবে, সো ইফ ইউ ক্যান ম্যানেজ। আমি আসি।